When we look at naming, it's given a fancy name which is called nomenclature, but really it boils down to naming. We use the system produced by IUPAC, which is the International Union of Pure and Applied Chemists. That's all a whole bunch of fancy information just to say this is how chemists across nations have agreed to name organic compounds. So, what we've already talked about when we looked at substituted alkanes, but we'll talk about it a little more in depth now, is that, again, the stem or the root of the name is based on the longest continuous carbon chain. It does not have to be aligned, remember, in a straight line. It can turn direction. So in this case, although you might be tempted to go straight side to side, what we see is that it has to be the longest continuous chain, which contains as many substituted groups as possible. So in this case, you'll notice that down here we have a chlorine. We're going straight across, even though it's the same number of carbons, you don't have that chlorine or that substituent group. So our longest chain is going to go straight across and down, as opposed to straight across left to right. In this case, there's 6 carbons in the longest chain, therefore it's a substituted hexane. Notice that hex over here is the root for 6, and because there's single bonds between all the carbons, that represents an ane, an alkane hexane. Now, substituted groups are not necessarily just carbon-based, although we've already introduced how to name those. We identify it by the length of the carbon chain. In this case, we've got 1, so that's a methyl group. In this case, we've got 2, so it's an ethyl group. This is a fancy one, which is an isopropyl group. It would look equivalent to this. So it's like a branched propyl group, which is why it's called isopropyl. It's got the same number of carbons as a propyl group, but it's arranged in a different way. And propyl is just a straight chain with 3, because prop equals 3. We also can see that we can substitute with halogens, chloro for chlorine, bromine, iodine, fluorine, and when we do so, we take the name of the fluor or the halogen and we change its name so that it has an O at the end. So chloro is from chlorine, bromine becomes bromo, fluorine becomes fluoro, and iodine, which is the funny sounding one, becomes iodo. So in this particular one, we can see that we have a 2-carbon chain off to the right here, which means that that's an ethyl group. And we have a chlorine group, so this is a chloroethyl hexane. Remember from what we talked about last time that we list those groups in alphabetical order. We can also use prefixes to tell us how many of each substituted group is present, if it's not 1. So that's di, tri, tetra, penta, hexa. These are the same as you had from covalent prefixes. So there's nothing new that you're asked to memorize here. Next, we number the carbons in the chain so that we get the lowest possible number or combination of numbers. You have to number from the same end for all substituted groups. Sometimes people are tempted to start numbering at one end and then switch to the other end to give a lower number to one particular group, but you always have to look at the lowest combination of numbers from one particular end. In this case, the chain can be numbered so that the chloro and the ethyl are 2 and 3, or 4 and 5. So obviously the 2, 3 is lower, so this becomes 2-chloro, 3-ethyl hexane. Note the numbers and letters are separated with dashes. If you had 2 adjacent numbers, they would be separated with a comma. Let's look at a couple of examples. Starting with the one on the left, we have to first identify the longest possible carbon chain. In this particular example, we're in a fortunate case because there's only one particular carbon chain to identify. So that's this 4-carbon long chain going left to right or right to left. Because it has 4 carbons, that makes it a bute. And because those carbons are attached only single bond to single bond, it's a butane group. Looking for any other additional groups which are not part of the carbon chain, we can see here we have this bromo group and another bromo group because there's bromines, and to change their name to say it's a group off of the chain, it's a bromo. So there's bromo. There are two of the same group, which means that this is dibromo. And the last thing we have to do is say where on the chain are those two bromines attached. Well, I can start numbering on the left, and it would go 1, 2, 3, 4. Or if I start numbering on the right, I would end up with 1, 2, 3, 4, giving me a lower set of numbers. So I'm going to start numbering on the left, on the right, 1, 2, 3, 4. Making this 1, 2 dibromobutane. Remember that when we deal with our numbers, numbers are separated by commas, and numbers and letters are separated by dashes. 1, 2 dibromobutane. The second example looks a lot more difficult, but really, as long as you can keep yourself organized enough to identify your carbon chain, you're going to be fine. So, looking at this particular one, I can go 1, 2, 3, 4, 5, 6, 7 across. I can always also go 1, 2, 3, 4, 5, 6, 7 down, giving me the same longest possible chain. In this case, it doesn't matter which one I do, but just to show you that the direction isn't important, I'm going to choose to circle this one. Okay, now that we've got that identified as our longest possible carbon chain, let's see how many carbons are in it. So 1, 2, 3, 4, 5, 6, 7, making this a hept. Because all the carbons are attached by single bonds, that means that this is a heptane. Okay, now let's look at our substituent groups, because we obviously have things which are not included in that longest possible chain. Here we have a 1 carbon group, which makes it a methyl. Here we have another 1 carbon group, making it a methyl. So we have 2 methyl groups. We also have up here a 2 carbon group, an ethyl group. We have to number it to give it the lowest possible set of numbers to all of the groups. So I can start down here and go 1, 2, 3, 4, 5, 6, 7. Or I can start up here and go 1, 2, 3, 4, 5, 6, 7. In this case, it doesn't actually matter which one it is, so you wouldn't happen to have a difficult example like this, but you're going to number it so that the lowest number goes to the alphabetized way. So we're going to go 1, 2, 3, 4, 5, 6, 7. So that my ethyl, which is going to go first, is going to get a lower number. I wouldn't particularly mind for this year whether or not you made the mistake and went from the other direction, because that's beyond the scope of this particular course. Normally you'll get examples which are very clearly one way or the other. So now I list them alphabetically. So this is an ethyl, and that ethyl group is attached to the 3rd carbon, so it's a 3-ethyl. Here we've got a methyl, but we actually have 2 methyls, so this is a dimethyl heptane, and those are attached to the 4 and the 5 carbons. Remember that numbers and letters are separated by dashes. So I need 3 dashes, and numbers are separated by commas. For those of you that are concerned about things being neat and perfect, sometimes this will take a bit of practice to make sure you leave yourself enough space, because clearly I've smushed mine together a little more than would be ideal. You're going to do a lot more practice of this out of the Hebden in a bit, and this is going to lead you into your practice questions for section 9.5.